So I'm sorry I had to divide this video. Um, yeah, we were speaking about long waves, and now I would like to speak about the short wave and what is the main characteristic when it comes to a comparison to long wave. So with the short wave, they bounce through the atmosphere, okay, or to be more precise, they bounce off the ionosphere, okay. They often travel by interacting with the ionosphere, which is a layer of electrically charged particles high above the Earth. Okay, so you can think of it as throwing a ball, really practically. The signal travels upward. Um, the ionosphere bends it back down to Earth, and which is also, of course, for us ham radio operators, very interesting. It may bounce several times, and therefore it allows to cover not only countries but entire continents. Okay, it travels along the ocean. A transmitter in Europe can sometimes be heard in North America and Australia, Asia. And of course, the advantages are worldwide communication. And you have smaller antennas because of the shorter of the higher frequencies. And you have a relatively low power transmitter that can really reach huge distances. Even weak transmitters, the ham radio people or CB radio people beyond among you know about QRP. QRP stands for low power communication. As practically speaking, we are talking about maximum 5 watt. Okay, so this is really low power, and once it gets up to the ionosphere, it just bounces back again. So, and in the best case, you can really cover distances of thousands of kilometers. Okay, with low power signal. There are, of course, disadvantages. The quality of the signal can really change during the day. Okay, there are some phenomena like fading. There are different qualities of signals depending on the time of the day, depending also on the season. It is affected by solar activities, so you cannot you can not really change this. Sometimes it works really brilliant, so really like it's a local phone call, and sometimes it doesn't really work. It does not work. Okay, so especially when you get through phenomena like a gray line. I think I explained about the gray line in an earlier video, but I can take again this interesting theme. When it comes to reliability, of course, the long wave is generally more predictable. Okay. If a station is in range today, it will be also in range tomorrow. Okay. Weather does not have really a big impact. Okay, in the summer, yes, because you have a lot of atmospheric discharges, and you hear it, but you would hear the station despite of thunderstorms. Yeah, I would say the reliability is there. The maritime communication has been, or they used long wave because it was or it is the more reliable wavelength. It's used for time synchronization, which also it has to rely on reliability. Okay. Yeah, but the short waves are more dynamic. Okay. Of course, you have to adapt during the day what time you should be on which frequency, but it makes it more fun, in my opinion. I mean, more or less, it stays that way. So it's not that you need to change every day a different band, but I would say it's more oriented around the seasons of the year. Okay. And of course, solar activity and sunspot cycles. Yeah, I would say this is more or less the most important. Oh, of course, let's speak about antenna sizes, and I think this is a point which could impact. Of course, does impact the station. Of course, you for the long waves you need very huge antennas. Okay, hundreds of meters of tails, tall towers, and it's of course a question also of money. Yeah, I think we also already spoke about it. Shortwaves, smaller antennas. Sometimes you even can use magnetic loop antennas, which makes it more easier to set up. And yeah, I think that's about it. Okay. So if you have any questions, please feel free to place them. And yeah, that's the difference between short and long wave. Bye bye. Ah, by the way, this is Hotel Bravo 9 Golf Foxtrot Papa speaking to you.